What if I told you you had the ability to predict how much of something you were going to sell, a good or service, based on a given price? So you could pick a price and then magically figure out what the demand for that good or service would be. And then you could also pick many different types of prices and once again predict how much you were going to sell of that widget, that drug, that doctor's office visit, etc. Sounds pretty magical, doesn't it? Well, that tool actually exists, and what it's called is the demand curve. And in today's lecture, we're going to be going over the demand curve, which is a very valuable resource for economists and managers in predicting their environment and looking at the demand for their goods and services and how those goods and services are priced. So today, what we're going to look at is what is the demand curve? Go over some basics there. We're also going to look at what influences the demand curve. How is it shaped? And how do you move the demand curve? We're going to go over that. And then lastly, we're going to go over some basic calculations using that demand curve and being able to come out with some of those magical numbers and figuring out what we should price something at, what the demand would be, or vice versa. So let's get started. Okay, so what is the demand curve? First, let's take a look at what the law of demand is. And the law of demand states that as prices increase, the quantity demanded decreases, which makes intuitive sense. Let's say, for example, you had a bag of Oreo cookies and they cost $1.25 a bag. You could buy a lot of them, couldn't you? But let's say all of a sudden those Oreo cookies are $10 a bag. You're probably not going to buy too many bags of Oreo cookies. So what the demand curve is, it's a graphical representation of this price and quantity relationship. And it looks like this. And you notice that you have on the vertical axis, you have price. And on the horizontal axis, you have quantity. And when you plot this relationship out, you get this downward sloping line. Now, for our cases today for the lecture, we're going to be using a straight line, but sometimes the line can have actually a little bit of a curve to it. But the one thing in general is that it is downward sloping. In most cases, is a downward sloping line. The way that you read it is, for example, let's say that at $30, how many units or quantity or widgets or what have you would you be selling? Well, it's very simple. You look at the price 30 and then look down to see what your demand would be, which would be 100. You could repeat this process also for $20. Let's say you priced your product at 20. Well, all of a sudden now your demand or quantity goes up to 200. And if you priced it at the bargain basement price of $10, well, now all of a sudden your quantity is gone up to 300. So that's a little bit about the demand curve. Just remember that it is a graphical representation of the law of demand based on a formula that you have derived through observations of the pricing of your product or goods or services. Now for this class, and especially this module, you'll be given this information. You won't need to calculate what that formula is. But now let's look at some other things about what influences the demand curve. Well, if you look at the shape of the curve, it's always that downward sloping appearance to it. But know that it can also be very steep or very shallow. Now that's called elasticity of demand. And that's something that you will go over later. Right now, just know that the slope, that's what it's officially called, the slope can be either very steep or very shallow. But also the demand curve can be shifted. You can actually have it move one direction or another. What influences that demand shift? First, you have beliefs. A belief about a product. So for example, I'll pick on the aspirin scenario. Right now, maybe you're in great health, you're in your early 20s, you never get a headache, you believe that you never will need aspirin, so you simply don't buy it. that can shift the demand curve. A population in general can have a certain belief about a product, good, or service. Maybe they believe that aspirin doesn't work at all, even though the science says it does, but maybe that's their belief. That can shift the demand curve, where if you had let's say a negative belief that a product didn't work, you'd require a lower price in order to sell the same amount or units or volume. Preferences, kind of linked to beliefs, but let's say you have a preference for a certain brand. Again, sticking with our aspirin theme, many people prefer brand-named Bayer aspirin over generic aspirin, even though they're chemically identical. Bayer can actually charge more for their aspirin simply because of the preference of some buyers for a brand name. The price of substitutes. Aspirin has substitutes. Maybe it's Motrin or Tylenol or Advil. If those prices change, that can affect or shift the demand curve. And then lastly, income. Let's say you are coming out of a depression or a recession and incomes are increasing. People now have more money to spend. So now they can stock their medicine cabinet a little bit better than what they did before, and now they can throw a couple extra bottles of aspirin in there just in case, because income has increased. So again, income can affect and influence that demand curve by shifting it one direction or the other. Now let's go over some sample problems. And in these sample problems, what we're going to be doing is making those predictions about price, about revenues, about demand. And we're going to use the example here for all of these various scenarios. And that is, a clinic faces a demand equation where the number of visits equals 400 minus 3 times whatever price. So you got your variables, which are visits, which is the same as quantity or demand, and then you have price. And we're going to go through each one of these scenarios and show how easy it is to calculate it. Okay, here's our formula. Again, visits equals 400 minus 3 times the price. You have your variable, which are visits or quantity or demand. They're all the same. And then you have price in there. What we want to look at is kind of on a true-false basis. To sell 250 visits, the price should be $50. Is that true or false? Now, as we go through all 6 of these examples, I will say that you can set these up algebraically if you wish, but I don't recommend that. I would just recommend that you do the plug and chug method. I'm sure the algebra gods are cursing me out right now, but I think the plug and chug method works very, very well. So let me show you what I mean by that. Okay, so we've got our information here. Let's plug it into the formula. We know that the visits should equal 250. 400 is a given, minus 3 times the price, which was given. And now simplifying that out, going ahead and doing the 3 times 50, which is 150. So I have 400 minus 150, and it does indeed equal 250. So that is correct. If I priced my visits at $50, let's say this was during a given week, I would have 250 visits, or I should have an estimate of 250 visits into my office. Okay, let's look at our next one. Again, here's our formula for reference. And true or false? Revenue will be $11,500 at a price of 100. Okay, again, you can set this up algebraically, but I recommend the plug and chug method. It works just as good, and you don't have to worry about making an algebra mistake. And this particular formula or question has one additional step, which is pretty easy, and we'll go through that. All right, so we plug in our information into the formula. Okay, so visits would equal 400 minus 3 times 100, so we know that the price was given at 100. What we want to find out are the visits. We work through the formula, so we end up getting 400 minus 300 equals 100. Just by coincidence, it equals 100 visits. So if you think about it, 100 visits times $100 each equals $10,000. Not true. So that one is not true. The revenue would not be $11,500. It would only be $10,000. Okay, our next question. Again, our formula. Increasing the price from 90 to 100 will increase revenue. Let's see what the formula says. Okay, so we have our visits. We don't know what that is yet, but we have 400 minus 3 times 90. We work that formula a little bit more, so it ends up 400 minus 100 or 270 equals 130. So 130 visits times $90 equals $11,700. Now, from the previous example, we already know what the revenue is for $100. If you like, you can run through it, but remember, $100 equaled 100 visits, which equaled $10,000. So increasing the price from 90 to 100 would not increase the revenue. You would actually have a revenue decrease. So you may want to stick with that $90 a visit. Okay, here's our formula again for reference. Visits will be 160 at a price of 80. Plug it into our formula. Let's see if that's true. Again, 400 minus 3 times the price, which in this case is given $80. Work that formula. And yes, indeed, the visits would equal 160. So that is true. Our next question is, revenue will be $12,500 at a price of $50 a visit. Well, let's figure out how many visits we're going to have. Again, we work through the formula. We come up with 250 visits. We're going to have 250 visits if we've now priced our visit down to $50. Work out the math. And yes, lo and behold, we will be making $12,500. That is correct. To sell 100 visits, the price should be $100. Now, if you like, you can go back to our question that we did earlier and already know the answer. But let's go ahead and go through kind of the plug and chug on the formula. We want to figure out our visits. So we got 400. That's a given. That's part of the formula. Minus 3 times 100. We always do the multiplication first. Now we have 400 minus 300 equals 100. That is correct. So to sell 100 visits, the price should be $100. It works out right to the money. So what should the demand curve look like for the particular examples that we used? Remember that we had that formula. In that formula, you could simply pick 3, 4 different points and plot them on the demand graph, and you would get this. Remember, price is going to be on our vertical axis and visits on the horizontal. And you can see that for any given price, you can calculate the number of visits. So I think you can see that by running through those examples and being able to predict your environment can be a very, very powerful tool for managers. Not only knowing how to predict the environment is required, but then what do you do with those predictions? So let's say, for example, you were going to lower the price of your visits down significantly. And now you're going to have many more visits, many more patients coming in your door. Do you have the staff available to handle those patients? Do you have the materials? Do you have the rooms available to handle those patients? So there's a lot of useful information that you can glean here that can help you predict and be prepared for changes in your environment. And that's all through the demand curve and its associated formula. Well, I hope this has helped in going through the examples today and helping to understand a little bit about the power of the law of demand and the demand curve. And as always, thank you for watching.